Hello, my dear friends. I welcome to my YouTube channel. Today, our topic is biomass as renewable resource for energy, chemicals, and fuels. For your information, biomass refers to non fossilized biodegradable organic materials obtained from plants and animals on a renewable basis. That includes waste and residues of wood, agricultural crops, aquatic animals and plants, municipal and other waste material as well. So if you look at the biomass materials or derived compounds is widespread, abundant, also economical. So these excellent features makes biomass a better and sustainable source for future requirement of chemicals, energy and the power. So today video will focus on the chances where we can use the biomass in order to get the numerous kinds of compounds, fuels and energy. So let's start the video. Now if you look at the heavy dependence on fossil fuels like petroleum and coal for the productions of chemicals and fuel is alarming, as it not sustainable in the long run. Even polymers, plastics, drugs, paints, and fertilizers are petroleum dependent. So, if you look at whole scenario, currently we are completely dependent on fossil fuels. We require power, we require petrol, we require diesel, jet fuel, LPG gas, etc. We are always looking towards fossil fuel. But my question to all of you, those who are watching this video, my dear friends, where is petroleum and how long it will last? Imagine one day has come in your life that you have luxurious car, costly vehicle, but you don't have diesel and petrol. What happened in that time? So, my dear friends, time has come and you need to accelerate our efforts. We should minimize the use of fossils based compound and try to use the biomass as sustainable resources in order to get the energy and chemicals. Now, if you look at the world demand of energy increases yearly by 2.3%, and almost 80% we are still dependent on fossil fuels that include petroleum, mineral coal, natural gas. We trying to employ other renewable resources like eolic, photovoltaic, thermosolar, geothermal and tidal. However, it only contributes 0.5% to the outcome of energy generation. Nowadays, we are focusing towards biomass, but its contribution is almost at 11% in order to generate the energy worldwide. And hence, we have to accelerate our efforts to use biomass as resources or as a feedstock in order to get a variety of compounds from them. There are different kinds of resources are possible. The biomass can be a sewage based biomass, it can be municipal solid waste, animal residue based, industrial residues, or forestry crops and resources, as well as agriculture crops and residues. So these are the various types of biomass based compounds we having. Now, if you have the biomass, it can be plant derived or animal derived or the waste material. These biomass we can convert effectively in the process called biorefinery. Biorefinery is nothing but a facility that integrates the biomass conversion processes and equipment to synthesize the fuels, chemicals, and the power. In a biorefinery, the biomass can be processed either biologically or chemically. And what happens during the conversion, whatever the amount of CO2 is released during aberrations of biomass based compound, that can be again utilized by photosynthesis process to generate the biomass. So if you look at the whole cycle or whole design is a cyclic process, and that is the reason the biomass is a very attractive renewable feedstocks. To achieve the goal of sustainable progress, biorefinery will going to play a vital role in a near future. So from the biorefinery, we can obtain fuels, energy, and chemicals. If you look at the composition of the plant biomass, and basically a biomass is a result of life on the earth, in which a simple molecule such as CO2, water, nitrogen, oxygen, and several others are activated because of a numerous biochemical process. Now if you look at the lignocellulose biomass is a most promising resources that can be utilized in a variety of way. It consists of mostly three part: cellulose, lignin, and hemicellulose. If you look at the cellulose is nothing but a polymer of glucose linked via beta glycosidic bond, and which actually gives rigid crystallinity to the plant based compound. However, lignin portion of biomass is a highly cross-linked amorphous polymer, and which is mostly consists of para-coumaryl alcohol, coniferyl alcohol, synapyl alcohol, and many more aromatic compound. And the hemicellulose is a amorphous polymer of lignocellulose biomass, which is mostly comprised of 5 different sugar monomers: L-arabinose, D-xylose, D-glucose, D-galactose, and D-mannose. So if you look at the plant biomass is very good resources to obtain many chemicals. So now if you look at the various aspects of this plant biomass, the compositions of hemicellulose, cellulose, and lignin can be varied, and can it depend upon the types of the plants and the parts of the plant. From cellulose and hemicellulose, we can obtain C5 and C6 sugar. Okay, so it can be xylose comes from hemicellulose, glucose comes from the cellulose, and these xylose and glucose molecule can convert into variety of the compound. So if you go for hydrogenation of glucose, you will get the sorbitol. Xylose undergo hydrogenations, will get the xylitol. On dehydration of glucose, will get the HMF molecule, which is also called 5-hydroxymethyl perfuril, and the xylose will give rise to the perfuril. In the same manner, we can obtain 3-hydroxypropanic acid, levulinic acid, succinic acid, lactic acid, ethanol, and these molecules can be effectively utilized for the antifreeze purpose, polyester resin, fibers, solvents, contact lenses, fuel oxygenated, pesticide, green solvent, biodegradable, polyethylene, like polymers, fuel, and oxygenate. Now on the same line, the lignin can be used in order to get variety of the compound, and ferulic acid and mostly phenolic compounds can be obtained from the lignin, and that can be employed as a flavoring agent, phenolic resin, fuel for heat and power generation. So now if you look at the complete picture of the biomass, it's a abundant molecule, and if you apply variety of processes, the many compounds can be obtained from these bio-based compound. Now here question here, how we can utilize, how we can upgrade this biomass compound. We cannot use these lignin, hemicellulose, cellulose as it is. You need to perform some processes, and that we will look at step by step. So if you are going for trans-esterification process, we can able to obtain biodiesel compound. We can also go for pyrolysis. Pyrolysis is the process where we heat the compound at higher temperature. We can also go for hydrolysis, liquefaction, combustion process, gasification process, fermentation, hydrothermal reactions, physical treatment, biological treatment, chemical treatment, and carbonization process also. Now, if you are performing variety kind of processes, we can get many compounds. Like bio oils is one of the main compounds obtained from the bio-based compound, and which is contain variety of the molecule. Almost 200 to 300 molecules can be there, including esters, acid, aldehyde, ketone, ethers, and so on. We can get various kinds of chemicals from bio-based compound. We can obtain from biofuels, electricity, heat, and variety of material including polymers, resin, and so on. So if you look at all bio-based compounds, if you treat properly and if you upgrade in a biorefinery, we can get a various kinds of compounds. So this video is specially discuss the different ways of biomass treatment and the compounds can you obtain from the bio-based design molecule, mostly lignocellulose biomass. Thanks for watching.